Alrighty, so we've got two-step equations with fractions. So just like a regular two-step equation, you've got to cancel out everything that's with the variable, get it by itself. So that means this 4/3 would need to go first, just like if it were a regular whole number. So to get rid of a positive 4/3, I'm going to subtract 4/3. Which will just cancel these guys out right here and leave me with a 7/6d. If I subtract that side by 4/3, I have to subtract this side of my equation by 4/3. -1 minus 4 is going to give me -5/3. So now I've got a 7/6 that I need to cancel out. We're going to remember from our multiplicative inverse property that if I multiply by a 6/7, that's actually going to cancel out the 7/6, and that is going to just leave me with a d if I do that. But if I multiply the left-hand side by 6/7, got to multiply the right-hand side by 6/7. So 5 times 6 is going to give me 30. 3 times 7 is going to give me 21, and it's a negative times a positive. This isn't quite simplified, though, either, because I can divide the numerator and the denominator by 3. So it's actually going to be a -10/7. Now, if you're like I am and you're not real crazy about those fractions, okay, there's another way that you could do this problem and get rid of all the fractions from the get-go. So I am going to show you what I like to do. Because again, I'm not real crazy. I make a lot of mistakes when I've got those fractions. So if it makes sense to do so, a lot of the time I will do something to get rid of all the denominators. So if I look at 6 and 3s, I see that the least common denominator for 6 and 3 is, of course, 6. So I'm actually going to go through here and I'm going to multiply all my fractions by 6 to cancel out the denominator. And as long as I'm multiplying everything by 6, it keeps my equation in balance. So here I can cancel because 6 goes into 6 once, 6 goes into 6 once. So now I'm only left with a 7d. 3 goes into 3 once, 3 goes into 6 twice. So that is going to leave me with an 8. And then 3 goes into 3 once, 3 goes into 6 twice. That is going to leave me with a -2. So now I have 7d plus 8 is equal to -2. A slightly easier two-step equation if you ask me. So now I'm going to get rid of that plus 8 with a -8. I'm going to bring down that 7d because those cancel. Left with a -10. Divide both sides by 7. So d is still equal to that -10/7 that I had before. I just didn't have to fool with all those fractions that I did in the other way that I worked it. So if what I just did didn't make sense to you, it's okay. You don't have to do it the way I just did it, but it's just something that I have found that's kind of handy. So now in my two-step equation, it's going to be a lot easier and more user-friendly if we turn this mixed number into an improper fraction. So that's going to be 11/2 minus u is equal to 9/4. So the negative is in front of the u. It's not in front of the 11/2. So the 11/2 is a positive 11/2. So I'm going to get rid of that 11/2 with a negative 11/2. Which means I need to bring down that negative u. It's still there. So in order to do 9/4 minus 11/2, I need to get a common denominator. So that 2 is going to have to change into a 4, which makes that 11 turn into a 22 because I multiplied them both by 2. So I've got 9/4 minus 22/4, which is a -13/4. Now, because it's a negative u, I divide both sides by -1. U is equal to positive 13/4. Now, I also could have done this using my method where I get rid of the denominators first so that I don't have to fool with fractions. I have a tendency, like I said, to do that whenever I can. So this is 11/2. Let me go back to this. So because I've got a 2 and a 4, I know the least common multiple of those is 4. So I'm going to multiply this by 4, that by 4, and that by 4. So I'm going to multiply everything by 4 to cancel out the denominator. So 2 divided by 2 is 1. 4 divided by 2 is 2. So now I've just got 2 times 11, which will leave me with 22. 4 times u is minus 4u. 4 divided by 4 is 1. 4 divided by 4 is 1. So that cancels out and just leaves me with a 9. So now I've got a 22 to cancel out. Bring down my 4u. Divide both sides by negative 4. See how either way I ended up with u is equal to positive 13 over 4. One way I just got rid of the fractions right away, and the other way I used the fractions. But either method is just fine, whatever works for you. For number 3, I've got a minus 7 over 8 I need to get rid of. I'm going to cancel that out with a plus 7 over 8, which is going to leave me with just that negative m over on the left-hand side. So negative 10 plus a positive 7 over 8. So what's going to happen there is that 7 over 8 is going to cancel out most of a whole, but it's still going to leave 1/8 left over. So negative 10 plus a positive 7 over 8 is a negative 9 and 1/8. There's technically a 1 in front of that m. That's why there's a negative 1 there. So I'm going to divide both sides by negative 1. So m is going to be equal to 9 and 1/8. So there are a couple of different ways you could solve this one for number 4. You could start off by subtracting 4/5 from both sides, but then I need to get a common denominator and all that stuff to make that happen. So I'm going to use my method of where I multiply the denominators out. So looking at that 7 and that 5, I know that the least common denominator is 35. So I'm going to multiply everything up here by 35. And because 7 goes into 7 once, and 7 goes into 35 5 times, now I'm left with a 5 times 2, which means I just have a 10. Because 5 goes into 5 once, and 5 goes into 35 7 times, 7 times 4 is 28. And then 35 times 9 means I'll have 315q. So now those fractions are gone. I'm going to subtract out my 28. So I've got a negative 18 is equal to 315q because those 28s went bye-bye. I got to divide both sides by 315. And I'm going to leave this as a fraction. Okay, so it's a negative divided by a positive, so I know it's going to be a negative fraction. And I can divide 18 by 9 and get 2. And I can divide 315 by 9 and get 35. So it's negative 2 over 35. Okay, number 5 is a bit of a booger, but we can do it. Okay, so the first thing that I am going to do is I am going to get rid of, even though this isn't normally the way I would do this, I'm going to go ahead and get rid of the, actually, first thing I'm going to do is I'm going to turn this mixed number into an improper fraction. So that is going to give me 12 over 5. And I still have this h divided by 1 over 3 right here. Okay. First thing I'm going to do is get rid of the denominators here. So how am I going to do that? Well, I'm going to look for the least common multiple, which is 40, because 5 and 8 both go into 40. So I'm going to multiply everything by 40 to get rid of those denominators, because 5 goes into 5 once, and 5 goes into 40 8 times. Now I've got 8 times 12, which is going to give me 96, because 8 goes into 8 once, and 8 goes into 40 5 times. 5 times 3 is 15. And for right now, I'm going to still leave this 40 over h. And it's still got a 1/3. Okay, so I'm going to subtract 15 from both sides. So I've got 96 minus 15, which is 81. And then I'm still left with this 40h divided by 1/3. Well, how do we cancel out dividing by 1/3? We multiply by 1/3. So if I multiply by 1/3 here, that is going to cancel out and just leave me with the 40h. I multiply this side by 1/3. I got to multiply that side by 1/3, which is really the same thing as doing 81 divided by 3. Well, 81 divided by 3 is 27. So now I've got 27 is equal to 40h. And I'm kind of running out of room here, so I'm going to put that on the next page. So 27 is equal to 40h. I'm going to divide both sides by 40. And I'm just going to leave it as a 27 over 40. Okay, for number 6, notice this time I've got variables on both sides. I need to get rid of one of those variables. So I'm going to take away the 5 over 9c because that one is the smaller one. So if I subtract 5 over 9c from both sides, so this one will cancel over here. That's going to leave me with negative 3/4. And then 7 over 9 minus 5 over 9 is 2 over 9c. So now I got to cancel out that 2 over 9. We know from our multiplicative inverse property, you do that by multiplying by 9 over 2, which will cancel. If I multiply that side by 9 over 2, I got to multiply that side by 9 over 2. So I'm just going to be left with a c over here. I don't have any canceling that I can do, so I'm just going to have to multiply straight across. 9 times 3 is 27, 2 times 4 is 8, and it's a positive times a negative, so it'll be a negative 27 over 8. So for number 7, the first thing I'm going to do, I know it'd be tempting to do distributive property right here, but you know what I want to do is just get rid of that 9 over 4 entirely. To get rid of that 9 over 4, I'm going to multiply by 4 over 9, because multiplicative inverse property says if I do that, it's just going to cancel and it's going to be gone. So then I'm just left with a w minus 1 over 9, because the 9 over 4 has canceled out. If I multiply it, of course, on one side though, I've got to do it over here on the other side. And I have a little bit of canceling I can do to make this easier too. 2 divided by 2 is 1, 4 divided by 2 is 2. So I can multiply straight across. 7 times 2 is 14. And 1 times 9 is 9. So then all I have left is a w minus 1 over 9, which I'm going to cancel out by adding 1 over 9. So that's going to leave me with w is equal to 15 over 9. Both of those are divisible by 3, so that's going to leave me with 5 over 3. Okay, for number 8, I've got a plus 5 that I need to get rid of first. So I'm going to take away 5 from both sides. So that's going to leave me with the y. Still got that 5 over 3 hanging out there. And then if I have 2 and 5, 6, but I take away 5, that is going to go into the negatives. And it's going to be a negative 2 and 1/6, which I am now going to turn into an improper fraction. So that will give me a negative 13 over 6, because it's going to be easier to work with here in a second. So I've got y divided by 5.3. How do I undo dividing by 5.3? 5 over 3, I'm sorry. Of course, I multiply by 5 over 3. Which means those will just cancel each other out. If I multiply that side by 5 over 3, I got to multiply that side by 5 over 3. And there's no canceling I can do, so I'm just going to multiply straight across. I'm left with a y over there. So 13 times 5 is 65. 6 times 3 is 18. And it is a negative 65 over 18. Okay, for number 9, if I were you, I would go ahead and start off by multiplying to get rid of all of these denominators. So since I've got a 3 and I've got another 3, I am going to multiply everything by 3. Because if I do, so 3 times 3 times 3. So this 3 and that 3 will cancel, which will just leave me with the negative 2p. That 3 and that 3 will cancel, which will just leave me with the plus 8. And then 3 times negative 3 means I'll have a negative 9p. Now I've got variables on both sides. Can't do that. So I need to go ahead and get rid of one of them. I'm just going to go ahead and get rid of the minus 2p. To cancel out a minus 2p, I'm going to add 2p's to both sides. I'm going to bring this down. Gives me the 8. Negative 9p plus a positive 2p is negative 7p. If I divide both sides by negative 7, that means that my final answer is going to be a negative 8 over 7. I'm going to write it out here to the side over there. Okay, for number 10, the first thing I'm going to do is turn these mixed numbers, because there's more than one, into improper fractions. So that is going to be a negative 15 over 7n. And then this one is going to become a negative 10 over 7. I would get rid of all those 7s if I were you. So I'm going to just multiply all these fractions by 7. So I've got the 7 and that 7 will cancel. So that will just leave me with a negative 15n. That 7 and that 7 will cancel. So that will leave me with a minus 6. And that 7 and that 7 will cancel. So that'll leave me a negative 10. Now I've just got a plain old two-step equation. So I'm going to add 6 to both sides. Got negative 15n is equal to negative 4. Divide both sides by negative 15. That negative divided by that negative will cancel. So then I've just got a positive 4 over 15.